This is a production of Cornell University.
And thank you very much for having us here. I want to touch bases just on a construction standpoint, what the owners can expect to happen on site, what needs to be in place before we arrive. Jessica and Dale both did great jobs of explaining a lot of the process of the cover installation. Most, if not all, of the photos that were shared today, good and bad, are from environmental fabric installations. We have been doing this for quite some time, since the mid-90s, all over the country and abroad as well. We've worked outside of the country with various different operations aside from agriculture. But with our focus here today, and the typical cover installed in the upstate New York, basically, is a 60 mil HDPE material. It's high density polyethylene. It's an industry standard for this application. In some of the industrial applications, we do use a thicker material, an 80 mil, even 100 mil thickness of the same material. What we need to happen on site, if it is going to be a 9-line system, we would like to see all of the mowing around the lagoon taken down. Anything hard stem that may be growing inside the slope of the lagoon would need to be removed. And we can apply, as Jessica showed, a geotextile fabric to help as a cushion layer and to protect any abrasion from happening to the bottom side of the cover. When the guys come on site, typically it'll be a group of 7 to 10 guys, couple of pickup trucks and an enclosed trailer. Minimal equipment is needed, typically a telehandler or a lull type forklift, as well as a mini excavator for any excavating that we may need to do. When we first come on site, we like to make a good introduction with the owner, find out exactly how he would like us to enter and exit his property so that we do not get in any way, shape, or form the daily operation of the farm itself. Once that is in place, we typically do not need a lot of help from the farmer. We certainly welcome all the time they have to come visit with us, but we're there to do our job, and we do not want to impede what they have going on the farm. So once the
Can anybody else hear Jason?
I'm not hearing anything.
Jason? Hello, Jason? I don't actually. Can you, right now we can hear you.
Okay, it's been unmuted. I'm not sure what's happening there.
I think it's the internet.
Okay, do you want me to continue? I'm not sure where you may have heard or where it may have left off.
I heard you talking about your relationship with the farmer when you arrive.
Okay, so like I said, we like to make sure we get his expectations for the way he wants us to come onto his property. Sometimes there's a back gate, sometimes there's different entrances they would prefer us to use, so we don't get in the way of the process of the farm. Typically after that, we do not need a lot of input from the owner. We do not want to get in his way or slow him down. We welcome him to come visit us and ask any and all questions. But on a day-to-day during construction, we are a self-contained unit, and we will stay right around the perimeter of the storage lagoon itself. Once we have all the landscaping done and the mowing has taken place and any vegetation has been removed, we need to establish that low water level, the stop pump, if you will, so that the level never is pulled down below the opening of the pipe, so we do not have gas backing up into manure collection areas or other areas that could cause harm to animals as well. Some piping, influent and effluent that may be existing and entering the lagoon at a higher elevation simply just needs to be turned down to where it can follow the slope down to the low water level. And once it's below the liquid, then we have that seal and we do not have to worry from there. It is important that at the time of the cover installation, the liquid is at the low level stop pump. That way enough material is introduced into the lagoon to allow proper fluctuation throughout the year as the lagoon fills and is emptied. You don't want to put stress around the perimeter trench. So it is important to install it at low water level. So during coordination, that would be the time for the cover to come out. The typical size job in New York that we have seen throughout the years, we are looking at about a 3 to 6 week on-site window. Again, it's a small crew. The cover is fabricated, as she said, in a manner that it's accordion folded, and then we launch it across and pull it across. So the cover can be built in a few days, and then it is launched across in one day and secured either into the anchor trench or welded to the existing liner. Again, as I mentioned earlier, the material thickness. Through the years, we have seen different technological changes with our material and our equipment as well. The material they're making these days are all a standardized material. There's really only 2 manufacturers left in the US, and they make the material to the same standard. That material, for a small additional charge, can carry up to a 20-year warranty. In Europe, the same material made to the same specifications can hold a 50-year warranty. Here in the US, 20-year is the max, and that is a prorated warranty that is given by the manufacturer. Us as the installer will help with any warranty claims. We will be the liaison between the owner and the material manufacturer to help decide who is responsible for what. Typically, as an installer, we would provide a 1 or a 2-year installation warranty. If properly maintained, there's not a lot of cover maintenance that needs to be done from the outside where you hire personnel. We ask that you visually inspect the cover, look for any debris that may have been blown out onto the cover. We want to keep the rainwater pumped down. We don't want it to overflood the cover, but we do want to keep some water in the troughs for purposes of cutting down the friction of the weight pipe on the cover itself. At any time during the life of the cover that there's a damage, whether it's natural or someone made a mistake or something, an animal got out on the cover and damaged it, we also, and all cover installers should offer a repair service where even if the hole is out in the lagoon, the crew is trained to come out and safely make that repair. Obviously, if any manure is introduced on top of the cover, there are services there to clean that and remove it as best we can, pump what's contaminated back into the cover to get you back to where you are dealing with clean water on top, so it could be either pumped off of the tile or collected for irrigation. Our service, we're here on the East Coast, but we work all over the country. I have many crews in California where predominantly all of our work right now is in California. We work year round because of the weather and the vast amount of dairies that are there. There are a tremendous amount of programs through the state of California, but developers and the potential for the use of the gas there has projects moving forward at a rapid pace, even without state and government funding. As far as environmental fabrics in the state of New York, we have participated in many of these programs, and we understand that the way the programs work, we are able to come in and install the cover, and understanding we need final approval before we would get paid. Where on a typical job, we would do progress billing on some of these because they happen so quickly. We're able to come in, fully install the job, and then once it's approved through the program, through the grant funding, then we're fine with getting paid at that point. There is a few other pictures if you want to go through some of these slides, and we can just talk about some of the prep there.
Are you?
So that's a liner going in. Yep, that's a liner going in. As you can see, it's just basic dirt work. We need it. We need the liner smoothed out. I know a lot of the new stores going in, and a lot of states are requiring a liner. We don't need it smooth as glass. We need it to be free of any big ruts or anything that could damage the liner. But our crews come in. The rolls are 22 foot wide, and they are placed in position piece by piece and then welded together. We've seen some examples, and we have a few pictures of some welding going on here. Each seam, where in this material you can see the seams are very defined. Each seam is tested independently with air pressure to assure that there's no leaks. You can go ahead and go. There's a couple. You can go back forward. There's another picture of the testing process, along with some of the pictures of the welders up close. But this material is thermally bonded, so it's heated and used pressure to bond it together in the fusion process, similar to how polyethylene pipe is fused. There you go. That's a picture of what the industry calls a wedge welder. This is what it predominantly does. All of your large seams and all of your production work is done. Underneath of that flap and the overlap, there's a heated wedge, and it's heated on both sides. And the machine actually clamps down using pressure to create the seam, and it actually is self-propelled. So there's wheels behind it that pull it through the seam. So our technicians are there to clean the seam and to keep it on track. The other type of welding is extrusion welding, which you see here, which is not unlike a large scale.
Jason, I think we lost you again. Can you hear us?
Comes out. This is done on any areas that need repairs. This is done in any areas where we have cross seams, like you see in this photo. Go ahead and go one more, please. Jen, are you with me? There you go. Okay, so this shows the testing procedure. That the vice grip is basically sealing off the end, and there's a gauge there hooked to the needle. That needle is put into the seam between the two wheels that actually provide the movement of the wedge welder itself. This is pumped up to 30 psi and can run the entire length of the seam as long as there's no cross seams or any damage in between. That's left in place for 5 minutes, and you typically will see zero pressure down from that, and you know the seam is going to hold fine. So here's another picture. You can see the track that it leaves behind it. The two outside are the wheel marks, and the center of that is the actual air chamber that's penetrated with that needle and tested. This is a basic flare controller. This flare itself is unlike what Dale showed us. Dale showed us an enclosed flare, which different programs throughout time have had different requirements for methane destruction. This open type flare with a shroud and an igniter typically was not approved for complete destruction, for accumulation of credits or any other type of process. But since then, time have changed where you get very minimal reduction because of this, because there is still total destruction. What Dale showed us is an enclosed flare, which keeps the flame inside of it entirely. This is a basic a torch, like you've seen at many landfills. The shroud around it is just for windbreak purposes. This one particular in this picture is powered by landline power. As Jessica mentioned, you're going to need power to the lagoon for your rainwater pumps. So this is a simple 110 connection, does not require any special electrical source or power provided there. We also do offer those who would prefer to have a solar system, and it's powered by solar. The technology has gotten much better through the years where those are much more reliable systems. These systems have a thermocouple that measures temperature to tell the igniter to cut on and off, and also has a power source to get that igniter sparking to light the gas off. All right, Jess, what else you got on here? Okay, this is very important, and Jessica mentioned this. Jessica Skinner mentioned this. This is something that we're seeing now that 10 years ago we weren't doing, but this is an emergency vent. It's very, very basic and very easy. And that valve that you see is typically left closed. And if there is an issue with evacuating gas, whether it's to the flare or to a generator or whatever purpose you have with the gas you're accumulating, this can be opened up. The stack is high enough that it allows the excess gas to vent to atmosphere, and this would prevent you from damaging the cover or potentially having it rupture or damage the liner from expansion. So these are something that we like to see. There's another picture. This is your flow meter. This is what's typically used in both systems. And our flare system that we provide, it has this flow meter, which has an accumulator on it, the totalizer. You can also hook this in where remote monitoring is possible through cell service, and data logger is possible, where you can not only accumulate the total flow, but you can have temperature for total destruction through the information from the thermocouple.
Jason, do you want me to go back to any of the previous slides that we might have gone through fast, or shall we start with questions?
Well, we can start with questions. Like I said, I think that Jessica did a great job of explaining the installation process, and certainly my information will be attached. Anyone from any aspect is, I welcome you to give me a call. We can talk about what we've been doing. This system is something that is one of our more basic type systems, and it's more user friendly for the smaller scale farms. So we offer this all the way up to 30,000 head mega dairies out west. So we've got a system in place that we started out as a liner company. We've done a lot of cover work since the mid 90s, and this is what we focus on. So anyone I could help, anyone I could point in the right direction or provide any information for, I'm happy to do it.
Some questions. Is there a best season to install a cover?
Well, certainly in your area it is. We need drier temperatures. When we start getting late in the year, and we've been in upstate New York to Halloween and going into November before we've had heavy snow, but it's not just the wet, the condensation that accumulates. If you could imagine, it's plastic welding, so any moisture that gets in between there can cause an issue for quality. So we need drier seasons for sure. We typically work north during the spring and summer and work south as much as we can. And again, in California, it's year round. The rain season's hit or miss. And
I have a particular question. We were told that this gas is wet. Do you have any problems with anything breaking in the winter because of the wet gas? Have you seen that?
The condensation, and one thing with these systems is the gas production crawls during the winter. Because these are ambient temperature digesters, we're not seeing huge production during the winter. But the condensate trap needs to be drained periodically. Again, like Dale said, he vents it off when it's at low production. Some folks close the valve and store it under the cover. But we try to install below the frost line. And we have not had any issues with freeze ups during the winter.
Do you have any supply chain issues, availability, cost of materials?
Well, yes, absolutely. Like everyone else in just about every walk of life, we have seen the material pricing level out. We have actually went a couple of months without the dreaded increase as we've seen throughout in the entirety of 2021. The products that we use are typically available, and we are able to order them enough in advance and keep some in stock. We do try to utilize local folks, especially for the concrete, for any PVC and for any usables that we are going to use on site, we try to purchase those locally. So area to area, it may be a little bit harder for certain things, but right now we're seeing PVC as a problem. Of course, the pricing for everything is up. But I hope that that's going to continue to stay where it's at, and then we'll see it start backing off. It was tremendously low for a long time, so some of it may not just be supply chain.
Are you aware of programs through which farmers can sell carbon credits based on the volume of methane that is flared?
We do have some relationships with some folks, and that has actually became more and more of a reality. Through the years, it's been more of a mythical kind of a thing. It sounds good, and we've had clients talk about it, but the value of it really wasn't there. But we're starting to see not only credits, but we're also starting to see ways to utilize the gas that are obviously going to be returned in cash. So certainly there's as we move forward, the technology is definitely moving in the right way.
Do you have experience advice about covering concrete circular or rectangular tanks?
We have covered all types. The biggest thing is going to be how you attach the cover and how you access the manure itself or the liquid itself. If there are ways in place to do your mixing and to do loading and unloading, we can certainly attach a polyethylene cover to a concrete structure. We have them both supported and floating. Again, as you start getting into more and more of the supported and tent type and inflatable type covers, the costs are going to go up. Your in-ground digesters are certainly more economical.
And so a question about the cost related to if you put in a cover at the time that you put in the storage versus putting in the storage and then coming back sometime later to put in the cover. Can you give us a sense on if it's more cost effective to do it all at once or marginal?
Well, depending on the size, you're going to have some shipping savings if you are able, if your liner itself has a partial truck or not an entire truckload. So you'll have some savings there. But obviously the more material that we purchase, we typically get better pricing. So there could be some small savings there as well. The biggest thing is that when we do the liner, we have to come back anyway, because there's going to be some time where they're filling the lagoon. So while we're waiting to get to the stop pump low water level, we typically demobilize to another project. So it's not anything that we can just continue on as far as time saving.
Super helpful. Thank you so much, Jason. This was fantastic. Truly appreciate it.
This has been a production of Cornell University, on the web at cornell.edu.